So let's take a look at these two programs that we just saw in the previous video using getcar, putcar, and getc. So remember, getcar gets a single character from the standard in, returns an int, but it's just a single character. Remember, character is 1 byte and int is 4 bytes. So it's only the last byte of this 4-byte int that we really need. Putcar puts a single character to standard out and returns whatever it puts out. And we saw how we can set up a simple echo program by getting characters from the keyboard, essentially, until you get basically a control D or end of file. And then as long as it's getting something other than the end of file, it'll echo that out to the screen. But you won't see anything until you hit a return. And the return is also echoed, so you might want to note that it looks like you just type in something and then you hit enter. It seems to be taking that and printing that line out, but all it's really doing is echoing out characters that it reads from the keyboard. So let's take a look at that first. So I believe that is in the system. In my file says length 17-3. There it is. Let's compile it. Oops. 17-3 3.c. Okay, let's run it. 17-3. So one of the things is when you run this, it doesn't look like it's doing anything. It looks like it might be hung, but no, all it's really doing is it's stuck in that loop, and it's basically waiting for us to enter something right here. So it's stuck right here. It's called getcar, but it hasn't returned from getcar yet. So we type in one word or a letter, and you can keep typing stuff and nothing happens. So you might remember that I said it's just all it does is echo. Well, the thing is, it won't quite get to put anything until the buffers are flushed. So then a whole bunch of characters get read and put back out to standard out. So as soon as I hit enter, a whole bunch of them will go. The program goes through a whole bunch of these iterations of the while loop. The thing is that if there wasn't a buffer, it would read one character, print it out, one character, print it out. But instead of that, what happens is every time you add some characters, it goes into a buffer, sits in the buffer until you hit return, and then the buffer is flushed. That is, getcar starts returning, and then it reads a whole bunch of these things at a time. So it looks sort of like it's echoing lines, and that's what it ends up doing. Even though when you look at the code, it looks like it just reads in a single character, puts it out, single character, puts it out. Nope. Because of the buffer, it behaves a little bit differently. Okay. Next up, let me just show you how you get out of this loop. So we are still stuck in this loop. There's only one loop in that program. We're stuck in it, so you can type whatever you want. And until you hit Control D. So when I hit Control D, and then it stops. Okay, so Control D puts an EOF, end of file, and that's when this program reads the EOF, it exits the program. Okay, so next up, let's take a look at very similar program using getc and putcar. So getc reads something from a file, and then putcar puts it out to standard out. So you can sort of guess that what this will do is read from a file, character by character, until you hit the end of file, and every character it gets, it'll put out to the screen. So in order to be able to read from a file, we have to do a couple of things. We have to open up a file for reading. So in this case, what we're going to do is open up a file called test. It's probably not the best name for a file, but oh well. So what if the file doesn't exist? If the file doesn't exist, fopen will return an error condition, and then this will fall apart and you won't be able to close it. You'll probably get an error message. Let's see what happens. Once again, let's just walk through this program. We need standard.io.h for getc, putchar, fopen, file. All of these things are defined in standard.io.h. If you see something like this, of course, as we saw before, this is just a type. Actually, it's a complicated thing. Let's not get into exactly what it is, but it's just a type. And so putting the star f after it says that f is a pointer to this thing, whatever it is, of type file. You can probably guess that it's pound defined in stdio.h, but let's not worry about that. Let's just consider it as one thing. It's a file, and f is a pointer to file. After you declare f, you can say that f is equal to fopen. If you take a look at the man page for fopen, you should see that it returns, it's not obvious, but this is fopen. It returns a pointer to this file object, whatever that is. And we're not going to worry about exactly what that is. Okay, so that's why this works. And we could have put this all on one line. We could have said file star f equals fopen. That would have been fine. Okay, so you can take a look at the man page. We don't need to worry about that so much right now. We will get into more details of file I/O later too. But basically what we need is the name of a file, and that's what this string represents, and then the next argument, and there are more arguments, but we're just going to use one. The next argument is the mode in which you want to open the file. The R stands for read, and so you could have opened it, we could have opened it as read write, but we don't need any of that. I mean, we need just the read. We're just reading the file. Once we see that, then the rest of this is sort of very similar to the program we saw in the last program that we saw. Instead of getcar, we're using getc and in parentheses f. Most of the time, we don't use getc or the put version of getc, which is putc, which puts stuff out either to standard out or to a file. The reason for that is getc is a macro. And let me just take a look at this. Man getc. You see a whole bunch of related functions. Typically people use fgetc instead of getc. And the reason for that is I believe fgetc is just older. And also getc is a macro that expands in line. So if it's fine to use, there's probably no problem with using it. It's an alternative, but it does exactly the same as fgetc, and most people use fgetc. Okay, so having said that, you can try it out either way. Getc or fgetc works the same. It should work the same. Once we are done echoing everything or printing out everything that's in that file called test, we can close the file and exit out of main. So let's take a look and see how it works. Okay, here it is. Let's compile it. GCC -o. Alright, no problems. And if you run this, remember, so this is not going to work, but let's just see what happens. The reason it's not going to work is because I don't think I have created that file called test. So let's see what happens if you try to read from a file that doesn't exist. So remember, this program is going to try to open a file called test in read mode. and then get each byte from that file and put it out to the screen. What happens if the file doesn't exist? Oh, there you go, segmentation fault. So on this particular system, on this Mac OS X machine, I get a segmentation fault. You might see something slightly different on a Linux machine, on an actual Linux machine. So let's create a test file. Okay. Put some text. It doesn't matter what it is. And I'm going to hit Control D to stop that file. So in cat test, and there it is. So that's what we should see when we run this program. And now let's try it, like 17-4. Yep, exactly the same. So it works essentially just as if you had executed the command cat test. So cat just lists the contents of this file, and that's actually all this does. Only this program is specific to just this one file test. Cat can cat any file. With a few modifications, we could actually make this behave just like a cat file name sort of command by reading in things from the command line. That's command line arguments, but we're gonna deal with that with command line arguments pretty soon. Not quite yet. Okay, so try this out. Try using fgetc instead of getc. Maybe change a few things. You might even want to try to open a second file and put each character that you read from test into the second file. Don't try experimenting with these things. It's not that hard. We'll go over how to do that next. Okay, so let's take a closer look at fopen and fclose. Fopen comes from stdio.h. It opens a named file with specified permissions and attributes and returns what's called a file handler. If fopen fails, it'll return null, and that's what we saw when we tried to open test and it didn't exist. We got a segmentation fault. So if we move test to test to read that, if we rename it and we execute this command, we get a segmentation fault. And we can guess that that's probably because fopen did not work. This file name, there was no such file with that file name, and so it returned a null, and then we tried to dereference it and we got a segmentation fault. We use the read mode, but there's also write for output, or A for append, B for binary, and so on, and you can combine them as well. If the file does not exist and you try to open it in read mode, fopen fails. If you want to open an existing file for reading and write to the end, use the string r+. If the file does not exist and you use W for the mode string, that means you're saying that if it doesn't exist, you can create the file, or fopen can create the file. If the file does not exist and you try to open it in read mode, the fopen returns a null. So there's slightly different behavior based on what mode you ask for. fclose takes whatever fopen returns, whatever this thing is returns, and you put that as argument to fclose, and it closes the file. Just like in Java, we do the same kinds of things. You open a file and close it. Okay, so next up, we'll take a look at putc. We saw how getc works. Next up, we'll take a look at putc, which is actually just completely equivalent to fputc.